Okay, students, so we're here talking about the perpendicular and angle bisector of triangles, part 1. So this is going to be like a movie with a slow beginning and then a really good ending, kind of like Star Wars episode 2, Attack of the Clones. It's kind of boring at the beginning, long, nothing much happens, and then the end is really, really cool. Alright, so we're given a segment, we're given this segment right here, we're going to find and label the midpoint. So we'll just call it A, B. We're going to be really creative. So what's the midpoint? Well, if you notice, we go down 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6, 7, 8. So we're down 4 over 8. We're just going to go down 2 over 4. We're going to cut in half, and boom, that's the midpoint. I'm going to call that lowercase n. All right, midpoint was at -1, -1. All right. So it says, what's the slope of the segment? Well, we actually just counted it out. The slope, actually, we'll call this point C. That way we don't get too confused. Point C. And then we use slope as M. Doing so much math, we're already running out of letters. The slope, I said, was down 4 over 8. So that's -1/2. Okay? So we found the slope, we found the midpoint. Again, we're practicing a bunch of stuff we've learned in the past. Now we're going to write and graph an equation of a line that is perpendicular and passes through the midpoint of the given line. This is called a perpendicular bisector for obvious reasons. So perpendicular slope, opposite, reciprocal. So my new slope is going to be opposite, meaning positive. We change the sign, and then reciprocal, we flip it, so it's just 2. So it becomes positive 2 over 1, which is just 2. Furthermore, you remember we have this right here. We have point slope form. You guys did this in Algebra 1. We had a unit 3, where we did this. So you're going to take the point, we're plugging in the midpoint to these points. So you remember when you plug it in, you change the sign, and then that. So it says write and graph. The equation is going to be y plus 1, because you changed the sign, because the y1 was up here, and that's the x1. And obviously this is the slope, equals 2 parentheses x plus 1. So that's the equation. So it said write it. Now we're going to graph it. So really from this point right here, point C, the midpoint, well, we're going through that point. That's why we're using point slope form. So then I'm just going to do a slope of up 2 over 1, up 2 over 1, so on and so forth. And all right. So coordinate geometry, very powerful stuff. Very useful in today's world. Now, this orange line bisects and it's perpendicular to this green line. So it's the perpendicular bisector. Now, if we are good at math, the point 1, 3 should fall on our perpendicular bisector. Alright, so we are good at math. Why? I said this point should fall on it. It did. That's the point 1, 3. We'll call it D1, 3. Alright, now this next part is telling us to find the distance from 1, 3 to both endpoints. So basically what I want us to do is find this purple length and this blue length. Alright. So in this one right here, that's -5, 1, and then B is 3, -3. So we'll find AD using the distance formula. Big punch line. All right. Distance formula, very, very popular stuff. So we'll call that x2, y2. We'll call that x1, y1. Okay, so then as we plug in everything, we're going to get -5 minus 1 squared plus 1 minus 3 squared. And then we're going to get -6 squared plus -2 squared. We're going to get the square root of 36 plus 4, or the square root of 40. And we'll pause there. Alright, I don't feel like doing any more to that. We could plug it in and get a decimal, but we'll just keep it as the square root of 40. And then dB, we can use the distance formula to find dB, or let's use Pythagorean theorem shortcut. Alright, I like to practice distance formula. I like to practice distance or Pythagorean theorem shortcut. Both are useful. That has a 2, that's 6. So the length of dB squared is equal to 6 squared plus 2 squared. So dB is going to equal 36 plus 4. dB is going to equal, squared, rushed a little bit. Or dB equals the square root of 40. So that was the square root of 40, which is going to be about 6 point something. That was the square root of 40. So they were both the square root of 40, so these lengths were actually equal. Alright, so AD was the same length that was congruent to BD. Alright, and that's kind of the punchline. If a point lies on the perpendicular bisector of a segment, then is equidistant to the endpoints of that segment. Alright, and that's the punchline. It says draw a picture, so we just got some random segment. Alright, we're going to draw a perpendicular bisector to it. How do I know this purple segment is a perpendicular bisector? Because of the markings. So basically what it's saying is that these red segments are congruent. If a point is on the perpendicular bisector of a segment, so basically it's saying point A right here is on the perpendicular bisector of a segment, then is equidistant to the sides. So the length of AB is equal to the length of AC. And again, this is kind of like a movie with a boring beginning. Who really cares about this? Why do we need to know this? We'll just stay tuned. Some really, really cool things are going to happen. Alright, well, let's just do these follow-up problems. Some boring follow-up problems, and some juicy stuff's going to happen at the end. Wow. Alright, so find the value of x and the lengths of WZ and WY. So remember, perpendicular bisector, so that means that 2x plus 11 is going to equal 4x minus 5. And really that's the punchline right there. Once we get this far, I believe in your guys' ability to solve things. We're going to subtract 2x from both sides and add 6 to both sides. We're going to get 17. Or excuse me. Whoa, time out. Why did I write 6? That should have been a 5 all along. Hopefully some of you guys caught that mistake. Oops. Brain fart. I've been in quarantine too long. I'm slowly losing my mind. So x is going to be 8, and then you plug it back in. You guys can do that on your own though. That should be the same answer. Just saving some time. So number 3 now. OQ is the perpendicular bisector of MP. So it's saying it's the perpendicular bisector. Alright, which segments in the figure are equal? Well, a ton of them are. MO is going to equal OP. In fact, I just did those marked right there. Since Q is on the perpendicular bisector, MQ and PQ are equal. And then this one is clearly congruent, the 15s. So that's ML and PL. Alright, that's it. Alright, those are all the congruent segments. So that's part A. Part B is find X. Well, we already marked it right here. That's congruent to that. So for part B, we're just going to say 11 equals 4x plus 3. subtract 3, we're going to get 8 equals 4x, comma, x equals 2. And then is L on OQ? How do we know? The answer is yes, because ML and TL are equal. So since they're equal, it's going to extend right through that from the theorem we learned above. Alright, so stay tuned, watch the next videos, knock these notes out, make sure we submit them for a grade. Crazy things are going to happen in these next parts of the video.